Okay, this is going to be a review session for Exam 1. It's optional, but highly encouraged. So basically what I'm going to do is, I've got the e-textbook up right now, and you can see that there's 8 sections. I want there to be around 20 questions, and you'll have 75 minutes to complete it. And you'll actually be given the questions in my math lab, but you'll write your answers out on a piece of paper showing each step for your solution, and I actually grade what's on your paper, not what you type into my math lab. So I'll have more instructions on that later. So what I decided to do for this is I've already uploaded a practice exam. I think there's about 36 problems on it. I've changed some things around since I first uploaded it, but let's just say over 30. So there's more questions on that than you will actually be presented. And for the review, what I've decided to do is I want to keep things basic. I realize you're learning from home, and this is not ideal. So the actual exam will be very, very close to the questions that you are presented with in the practice exam. So that's one of the reasons I'm doing this. So you might want to wait until you've gone over the practice exam problems and then watch this video, or watch this video and maybe have the practice problems there with you and try to work them along. But if you have any questions of anything that I do today, of course clearly we can't interact because I'm taping this and then posting it later on, but you can always email me. And don't forget the Ask My Instructor tool when you're doing your My Math Lab homework. It will literally email me the problem that you're working on. So the first problem I want to do is, I don't know, I'm going to use this. I just printed out a copy with the answers. And if anyone wants a paper copy of the practice exam with the answers, you can tell me. I don't know that the questions that you get are going to be the same as the ones that I printed out. Not exactly how my math lab does that. If it changes the homework for everybody, hence it's changed for me, and you'll get something slightly different. But we're asked to solve this equation, and it's an equation in the variable t. So what we want to do always is we want to find the LCD. It has a fraction in it of the denominators. And the LCD of two whole numbers is always greater than or equal to the largest of the two. And it's actually equal to the largest of the two if the smaller of the two, in this case 9, evenly divides 18. And 18 divided by 9 is equal to 2, so that the LCD is equal to 18. Oh, this is a completely different question than I was going to give you already. So it may have already generated another question. So this is similar to, I've given you a homework where you upload a PDF. It's very, very similar to that one. So what I want to do is I want to take, well, that will do. I want to take and put everything in parentheses. And then I want to multiply each side by 18. Over here on the right, I'm just going to put my 18 right there, because some expression a times 18 is the same as 18 times a. I'm just using the commutative property of multiplication. So here we go. Notice this is 18 times 1/9 times 9t minus 7. So 18 times 1/9 is this. So So literally I'm just multiplying 18 times this. There is no distribution here. This is a product. Distribution works when you have a sum or a difference. There isn't a sum or a difference here. This is 1/9 times what's in parentheses. So this is a product. So this is the same as 18 times 1/9 times 90 minus 7. But 18 divided by 9 is 2. And that's multiplied times 9t minus 7. And over here, t plus 7 divided by 18 times 18, well, the 18's cancel out. This gives me t plus 7. So now I can use distribution. Here's where we have distribution. I have to distribute the 2 from here to here. And you should know that because you've already got through the gauntlet of intermediate algebra. 2 times 9t is 18t. 2 times minus 7 is minus 14. And that's equal to t plus 7. So what you want to do is you get all of your variable terms on one side and your constant terms on the other. So I'm going to move the t over here. And when I move it across the equal sign, it changes its sign. And I'm going to move the minus 14 over here. The 7 stayed, and it's going to be joined by the 14 with its sign changed. So 18t minus t is 17t. And 7 plus 14 is 21. So I know how many 17t are. I want to know how many 1t is. So I divide each side by 17. My answer is t is equal to 21 divided by 17. Okay, not so bad, right? Not so bad. So let's do another one. I have this as problem 4. So we're going to solve, nope, we're not going to do problem 4. That's one of the ones I changed. This is problem 3 in your practice test. You will be given one identical or similar to it. We want to solve for a variable. So I have a is equal to 1/2 times f times r plus b. And we're asked to solve for r. So again, we have a fraction here on the right hand side. Just one fraction, only one denominator. So we multiply both sides by the denominator value. Over here, no need to put parentheses because there's only one item, one term on the left-hand side. But over here, I'm just going to remind myself that I need to put parentheses there. Now in this case, since this is a product, this is 1/2 times f times r plus b in parentheses. These blue parentheses that I've just written aren't that necessary, but it's a good habit to keep. In other cases, this won't be a single product, it will be a sum or a difference, in which case you have to remember to distribute the 2. In this case, it would be the 2. So on the right hand side, I have 2a. And 2 times 1/2 is just 1. So 1 times f times r plus b is just f times r plus b. Now again, there's two ways you can go here. I want to get the r by itself somehow. Right now it's kind of locked into this parentheses. Well, one way I can get it out is to divide both sides by f. So this gives me 2a divided by f is equal to r plus b. and I want to solve for r. So at this point, all I do is subtract b from both sides. So I get 2a over f, sorry I'm using a cursive f, minus b is equal to r. Another acceptable way to do it, starting right here at 2a is equal to f times r plus b, is to use distribution. So that's going to get me 2a is equal to f times r plus f times b. Well, the r term is the one I want to isolate, so I subtract fb from both sides. Now I know how many f times r is. I want to know how many just one r is, so I divide both sides by f. So that's going to give me 2a minus fb over f is equal to r. The only part about doing it this way, I'm okay with this, is my math lab will want you to simplify it. And the rule for simplifying that is just the same rule we've used again and again and again. And if we have a plus b, or for that matter a minus b, divided by c, that's equal to a over c plus b over c. That said, this is equal to just simplifying the left-hand side, this right here. This is 2a over f minus fb over f is equal to r. But now you can easily see that f there in the numerator of my second term is going to cancel out, and literally I'm going to get the exact same equation that I got earlier when I did it the other way. Okay, so solving an equation for a variable. Let me see if this... Nope, I'm going to do the one, I worked some of these out beforehand just to avoid having to think too hard while I'm taping, because I've got other things going on. But this one's going to be similar to question number 6. And literally when I just printed it out, it changed the numbers from what I previously had, so that I now know the answer to my question. So this is number 6. And this is a question about interest. So simple interest. So we have the formula. Simple interest, I, is equal to the principal times the rate times the time. So in this case, somebody named John has $160,000 to invest. And he wants to invest each one at an annual rate, at 2 different annual rates. Rate 1, he wants to invest at 11%. That's going to be rate 1. And rate 2 is going to be equal to 8%. And he wants to invest them for 1 year. So he wants to know how much money to invest at each of these different rates so that his total interest after 1 year, so total interest after 1 year, and that's usually marked by annual, is equal to $15,350. So he's going to split his total money into two different parts. One part he's going to invest at a rate of 11% interest, and the remaining part he's going to invest at a rate of 8% interest. So let's let X equal the amount invested, and you get to choose that, but I'm going to say at 11%. So if he has $16,000 and he takes from that, he's going to invest all of it, right? So if he has $160,000 and he invests X amount at 11%, how much does he have left? Well, we don't know what X is, but whatever X is, if he subtracts that number from 160,000, that's how much he has left, and that's going to be the amount at 8%. So let's write a guiding equation. So total, and by that I mean total interest earned. This is an important part, I think, is equal to interest, interest, earned at 11% plus interest earned at 8%. And the time frame is 1 year, so our t is just going to be a 1. So let's now formulate an equation. So we're going to be using this formula. This is simple interest. It's not compound interest. It's simple interest. So the total interest he wants to be earned after 1 year is $15,350. But that's the interest earned at 11%. And X is the amount at 11%, so X is our P, times our rate, which is 11 divided by 100, times our time, but T is equal to 1. So I'm not even going to bother to write it. But if you wanted to, you could write times 1. But that doesn't affect anything. And then the interest earned at 8%, well, our principal is $160,000 minus X, which is the amount invested at 11%, times our rate 2 in this case, times 8%, 8 over 100. So now all we have to do is solve this equation for X. And I don't want you using calculators. I will discuss a calculator policy, and this might be one of them that I would be okay with you using calculators, but I would prefer you not. So we're not going to solve it with calculators. What we're going to do is we're going to clear the denominator. So I have two fractions here, 11 over 100 and 8 over 100. So I'm going to multiply both sides, and that's what makes it so nice, is I'm multiplying both sides by 100. And when I multiply a number by 100, all I have to do is attach 2 extra zeros to it. So now that's the original number. I'm just going to add 2 extra zeros. And here I'm just distributing, so that means the denominator is going to be cleared. X times 11 divided by 100 times 100 is just 11x. And 160,000 minus x times 8 divided by 100 times 100 is just 8 times 160,000 minus x. So here I need to simplify the right-hand side. So again, I want you to actually figure out what 8 times 160,000 is. But we're going to do a little trick. I'm going to find out what 16 times 8 is. Well, 8 times 6 is 48. 48. 8 times 1 is 8 plus 4. That's 128. So I'm going to replace 16 by 128. So I'm getting ready to write it out. $16 is going to be replaced by 128, and then all of the zeros stay. And then 8 times minus x is minus 8x. So now I can collect like terms. 1,535,000 is equal to 11x minus 8x is equal to 3x plus 1,280,000. So now I have to move the constant terms over. So I have 1,535,000. I don't know what I just said there. 1,535,000 minus 1,280,000 is equal to 3x. So now I have to subtract these two values. Well, I just ignore the zeros, and I'd come over here, 1,535 minus 1,280. Well, that's 5. I will borrow a 4. 13, that's 5, 2. And those are 0. So I replace 1,535 with 255, and I attach the zeros. So now you're really dying to get out your calculator, but don't. There is a divisibility by 3 test. Is this evenly divisible by 3? Well, the way we know is if we add up the digits, and if the addition of the digits results in a number that's evenly divisible by 3, then it's evenly divisible by 3. So 2 times 5 is 7. 2 plus 5 is 7, and then add another 5 and I get 12, and 12 is evenly divisible by 3. So I'm going to come over here and do it. So I'm going to divide 3 divided by, this case, just 255. And just ignore all of those zeros. Well, 3 will go into 25 8 times. And 3 will go into 15 5 times. So I replace 255, so I'm dividing both sides by 3, mind you. And I just discovered that 255,000 divided by 3 is 85,000. And that is equal to x. When that's how much he needs to invest at 11%. And how much does he need to invest at 8%? 160,000 minus x, which is 160,000 minus 85,000, which turns out to be 75,000. So at 8%. And if he does so after a year, he will have a total amount of $15,350. It's a lot of interest after 1 year, but you know, who has $160,000 to invest? But it does show you that, and who's going to get an interest rate of 11% and an interest rate of 8%. Anyway, these are applied problems, but they're not necessarily problems used with numbers in real life. In real life, you would want to use the calculator because the numbers were chosen to make the solution simple and things that you could do without having a calculator. Real life problems, and one of the reasons I like choosing interest rate problems is because there's something you really will have to use in real life. I know you say, well, I'm not really, because there's apps. But would it be nice to be able to check the app, make sure it's right? So this is going to be a multiplication. We're into complex numbers. This is question number 9. So here's to review. A complex number is a number in the form A that can be written in the form A plus B times I. I is equal to the square root of -1, or an equivalent definition is I squared is equal to -1. A and B are real numbers. So when B is equal to 0, the resulting number is a real number. When A is equal to 0 and B is not, then the resulting number is called a purely imaginary number. When neither A or B is 0, then we have a complex number that is not a real number, a complex number. Actually, they introduce all of these confusing terms in the book. Those terms are not standard. When I want to talk about, and when in all of my math education, which is years, if we want to talk about a complex number that's not a real number, we say a complex number of the form A plus BI, where B is not equal to 0. At any rate, we have one little aspect. Given a complex number A plus BI, remember A and B are real numbers, so we don't know if they're positive or negative, but if B is negative, we just have A plus a negative number, which we normally write A minus BI. The conjugate, we leave the value of A alone, and all we do is we change the sign. The conjugate of this complex number, conjugate, these are conjugates. So given a complex number, we can find its conjugate always. Even if A is equal to 0, like 3i, we could write as 0 plus 3i. And its conjugate would be 0 minus 3i, or just minus 3i. So 3i and minus 3i are conjugates. The point is, when we multiply two conjugates, A plus BI times A minus BI, and of course this is multiplication, so you can multiply in any order. We have an almost magical product. The product is, I just take the A term and I square it, and I add it to just the B term squared, and whatever that B term is, you can take the minus B or the plus B, it doesn't matter because they're real numbers, and in real numbers minus A squared is the same as A squared. So we're going to use that trick in finding out what the product of these three complex numbers are. If you were to do it any other way, excuse the pun, you would make the problem far too complex. So I'm multiplying A times B times C. So when I do that multiplication, I can do them in any order I want. So in this case, I'm going to do A times B first, excuse me, and find out what that product is, and then multiply it by C. Why did I choose it? Because A and B are conjugates. Now if I had 4 plus I times 3 plus 2I times 4 minus I would just rearrange them, because A times B times C is the same as A times C times B. That's using the associative and the commutative properties. But in this case, they were kind enough to group the two conjugates right next to each other. So the literal product of these two conjugates is A squared, my A is 4 squared, plus B squared. Now B, this is 1 times I, so the B is 1. And then I'm going to multiply that. It's 3 plus 2I. So 4 squared plus 1 squared is 16 plus 1. I'm going to multiply it 3 plus 2I. But 16 plus 1 is 17, which I'm multiplying 3 plus 2I. Now it's just distribution. So 17 times 3 is 51, and 17 times 2I is 34I. And that's the answer. So another question related to complex numbers is division. I have 8 plus 9I divided by 1 plus 4I. We actually can divide that, and here's what we do. We multiply that quantity, that number, by 1. 1 in the form of a fraction. That means whatever the denominator is down here, the numerator must be the same. So how do I choose the denominator? I literally look at the denominator of my first fraction and I write its conjugate. And I didn't write its conjugate. Now I'm writing its conjugate. So that's going to get me an easy simplification. Now I'm going to have to do complex multiplication in the numerator no matter what. But that's just foiling. And remember that when you have I squared, you replace that by minus 1. And down here, this is just 1 squared plus 4 squared. So taking the problem on down to here, let's work on that denominator. So I'm just going to use distribution or FOIL. So 8 times 1 is 8. 8 times minus 4i is minus 32i. 9i times 1 is plus 9i. And 9i times minus 4i is minus 36i squared. And it's all going to be over 1 squared plus 4 squared. That's 17. So really all we have to do now is clean up the numerator. So I'm going to combine the two I terms. So minus 32i plus 9i is going to be minus, did I do this wrong? 8 times 8 is 60. 8 times 8. 8 times 4 is 32. And then 9i and minus 36i. Oh, okay. I'm fine. So this is minus 32i plus 9i, and that's minus 23i. I was looking at my paper, and I was worried about this term right here, but needlessly, let's think about this one. Minus 36i squared is the same as minus 36 times minus 1. So that's plus 36. And they're all over 17. Now we're almost there. So 8 plus 36 is 44 minus 23i, and that's going to be over 17. We want this in the form a plus bi, so we just use the same trick. A plus bi divided by c is equal to a divided by c plus b divided by c times I. So this would be written as 44 divided by 17 minus 23 divided by 17 times I. Okay. So on to another question. So this is number 14. So what we're going to do in number 14 is we're going to solve a quadratic equation by completing the square. So the only thing that I want to remind you of, the polynomial is monic. So we have the regular standard form quadratic equation, ax squared plus bx plus c is equal to 0. So this is a degree 2 polynomial. That's what I mean by the polynomial part of it. And of course it's set equal to 0. And when you say it's monic, means a has to be equal to 1. So if you were asked to complete the square and the polynomial were not monic, you would divide each term by a. Now 0 divided by a is going to leave a 0 over here, but you would get x squared plus b divided by a times x plus c divided by a is equal to 0. You may see one like that. I don't intend to put one like that, but I have a feeling one is like that on the homework. I instead chose an easier one. Like I said, I want to keep things basic. So I have x squared plus 3x minus 4 is equal to 0. So our first step is we move the constant term to the other side. So that gets me x squared plus 3x is equal to 0. So now what I want to do, what I usually do, is I come over here and I write my b term. So my b term in the original, my a term is 1, my b term is 3, and my c term is minus 4. So my b is equal to 3. So b halves is equal to 3 halves. And I didn't give myself enough room, but b halves squared is equal to 9/4. So what I do is I add that quantity right there, b halves squared, to both sides. So I have to add it to both sides to avoid breaking I didn't add 4 there. I just brought down the 0. There's supposed to be a 4 here. Let me correct that now. It's going to be equal to 4 plus 9/4. Now this is actually a perfect square. So its factorization is x, and what is my b half term? It's 3 halves. It's x plus 3 halves squared is equal to 4 plus 9/4. But I'm going to write 4 as 16 divided by 4 plus 9/4. So I'm just going right along. So now I'm going to simplify. I'm going to use the square root property to solve this. 16 plus 9 is 25 divided by 4. So the square root property says if x squared is equal to k, then x is equal to plus or minus the square root of k. So I'm going to take the square root of both sides. So taking the square root of x squared leaves x plus 3 halves. And it's equal to plus or minus the square root of 25/4. So that means, let's break it up. X is equal to, I'm going to move the 3 halves to the other side, minus 3 halves plus the square root, and yes, we are going to simplify that, 25/4, or x is equal to minus 3 halves minus the square root of 25/4. But up here, the square root of 25/4 by using our exponential rules from intermediate algebra is just the square root of 25 over the square root of 4. So that's equal to 5 halves. So, carrying on with this equation, that means x is equal to minus 3 halves plus 5 halves. Well, they share, how nice, they share the same denominator. So all I have to do is minus 3 plus 5 is the same as 5 minus 3. So that's 2 divided by 2, so x is equal to 1. That's one solution. My other solution is minus 3 halves. Now I've taken the minus 5 halves. And again, they share the same denominator, which is 2. Minus 3 minus 5 is minus 8. So, minus 8 divided by 2 is minus 4. Okay. Now, the next problem we're going to do has to do with the discriminant. This is the discriminant test. It's problem number 16. So we're given, I want to know what we want to do. We want to use the discriminant to determine number of solutions and the type, meaning what set of numbers do those solutions reside, type of solution. So we're given x squared minus 18x plus 81 is equal to 0. So that's the same as ax squared plus bx plus c is equal to 0. My a is equal to 1. My b is equal to minus 18, and my c is equal to 81. So the discriminant is given by b squared minus 4 times a times c. So b squared is minus 18 squared minus 4 times a times 81. Well, minus 18 squared turns out to be 324. And let's see what 81 is. 81 times 4, 4 times 8 is 24. Did I do that right? 8 times 1, sorry, 34. Oh. I'm so sleepy, people. Let's just use the calculator. Let me check. $3.24. I got that one right. And let's do the discriminant is 4 times 81. $3.24. I don't know what I did. Oh, duh. I don't know exactly what I did. 8 times 4 is 32. Yeah, well, it's one of those afternoons, people. So 324 minus 324 is 0. So our discriminant is 0. So now all we need to do is look at our discriminant table. I'm being really lazy. And let's go back to my e-text. Can I, or will I have to sign back in? Let's find that in the e-text. So my discriminant was 0. So this is going to be chapter 1, quadratic equations. And all we have to do is just go over a few pages. So there's a whole list. As far as notes going, I prefer you not to use notes because, for one reason, if you have to take a math class after this and it's face-to-face, you won't be able to. So here's our discriminant test. So if the result of our discriminant is a positive perfect square, for example like 25, because the square root of 25 is 5, then we would have two solutions, both of which would be rational numbers. They would be expressible as plus or minus, as integer, some integer divided by another integer. If the discriminant were positive but not a perfect square, we would still have two distinct solutions, and they would be irrational. If the discriminant is 0, which is our case, we're just going to have one solution. You don't have to worry about the double solution, and it's going to be a rational number. And if the discriminant turns out to be negative, you're going to have two solutions, and they call it a non-real complex number. What we always just say is a complex number of the form a plus bi, where b is non-zero. So in our case, our discriminant was 0, so we only have one solution. And it's rational. Okay. Let's do another one. Do 18. Okay, this is one of the box deals. So we're given a box. Within a box. It's the cut out the box deal is what it is. So here we have a box and another box inside of it. I'm just kind of sketching this out. Use another color here. and they cut out these corners. You can always open up your e-text and look at the picture there. So it turns out that the length of the box is, the length of the box is the width plus 10. The original, so this is this outer edge right here is just a sheet of metal, and it turns out the length is, say, 10 inches plus the width. So we're going to call this the width. In each one of these are supposed to be square corners right here. Of course, I can't call them square, but that's 2 because they don't look square. That's 2, that's 2. Hold on. Kind of blurs it a little bit, but still. That's 2, and that's 2. So what they do, I don't like it. I'm going to go back. That's good enough. So what we're going to do is we're going to be making, folding, those cut out things, and we're going to fold this into and this is, of course, is going to be terrible, but it's going to be enough, I guess you can imagine it, right? We're going to be folding it into a box or whatever you rectangular solid. So the question is, the length of this right here is going to be the length of this part right here. So that part right there in red is the same as this part right here. So let's find out what this is. So the total length here is 10 plus W, but then I'm taking 2 inches off either side. So I've got to take 2 inches off. So that's 10 minus 2 minus 2, which is 10 minus 4. So this has a length of 6 plus W. Now this part right here, the length of this part right here, is the same as this right here. So that was W, this outer one is W, and I'm subtracting 2 and 2 from it. So that's going to be W minus 2. And these little flaps, I mean, they're literally removing these corners and folding things up. That's what they're doing. Represents the height. And they want to know, this is a volume question. So volume, it's three-dimensional, is length times width times height. And they want to know the dimensions of the original rectangular sheet of metal, so that once they make this box, and this box has 1,302 cubic inches, what dimensions are required in the original rectangle to create it? Well, our length is 6 plus W. Our width is W. It's not minus 4. It's actually minus 2, right? Because we're taking we're taking 2 flaps away from it. So it's minus 4. That's the reason I do these in advance. And then we're multiplying all of that by 2. We'll put the 2 right there. So the easiest thing to do right here is to simplify by dividing both sides by 2. Now 1302 divided by 2 is 651. And over here the 2's cancel out, so I have 6 plus W times W minus 4. So you can see this is going to be a quadratic equation. So let's go ahead and solve it. This is 651 I have to FOIL or multiply these two binomials. 6 times w is 6w. 6 times minus 4 is minus 24. W times w is w squared. And w times minus 4 is minus 4w. So let's simplify the right-hand side by collecting like terms. 6w minus 4w leaves me 2w minus 24 plus w squared is equal to 651. So this is a quadratic. Our variable is w. That's our variable. It's a quadratic in w. So our ax squared plus bx plus c equals 0 is the same now as a w squared plus bw plus c is equal to 0. So I have to remove terms. I'm going to move the 651 over here. That'll give me a 0. I'm going to just rewrite my w squared at the first. Then I still have a 2w. Then I have my minus 24, and it's being joined by my minus 651 when I move it over. So that gives me 0 is equal to w squared plus 2w minus 675, which can be rewritten if you want as w squared plus 2w minus 675 is equal to 0. So we have to solve this. And here I don't know what to tell you. You cannot look at this right offhand and say whether it's actually factorable. You can actually factor it. You know that the quadratic equation always works. But the quadratic equation is going to require some big numbers. Well, this actually I did it before and it does factor. So I'm going to give you a clue. I'm going to tell you that 675, it kind of reminds me of something that can be divided by 25. Indeed, it can be. It's 25 times 27. So let's go ahead and use my method to factor it. It's not bad to review that method. So I guess I'm not done with it. Make a little table like this. At the top I put my w squared. Then I go to my constant term, minus 675. And on the bottom I put my middle term, 2w. So let's start up here. I have to have a w here and a w here, and I'm multiplying. W times w gives me w squared. Now I know 675 is equal to 25 times 27, but one of them has to be negative, because when I multiply them together I have to get negative 675. So I'm going to say minus 25 times 27 is minus 675. So that's satisfied. So we multiply that way. Now we multiply down. W times minus 25 is minus 25w. And w times 27 is plus 27w. And then the last thing we do is this is the addition one. And when we add these two terms, we have to get 2w. Indeed, 27w minus 25w is equal to 2w. So now I'm ready to grab the factorization. For the factorization, we have to do the kitty corners. If you don't remember this step right here, kind of looks like a helium atom maybe in the Rutherford model. We can factor it, and this is factorizable, is w plus 27 times w minus 25 is equal to 0. If you think it looks like it should be factored, you should try it. They put a lot of these, particularly create them so they can be factored. So I just use now the zero product property. This is sum A and this is sum B. And I know that if A times B is equal to 0, then A is equal to 0, or B is equal to 0. So that means W plus 27 is equal to 0, or W minus 25 is equal to 0. So that implies W is equal to minus 27, and the bottom one implies W is equal to 25. So W is equal to 25. So the width, my original, go back up to my picture here, so W is equal to 25. So this side length of my original piece of metal is going to be 10 plus 25, which is equal to 35. So don't forget, that's what they were asking, is the length of the width, the distance of the width, how long the width is, and how long the length is. So the width was 25 inches if the original measurement was inches, and the width is 35 inches. If it were to give it to you in centimeters, then it would be in centimeters, whatever. Okay. So this is problem number 20. This is a rational equation. So we want to solve 3x plus 1 over x minus 2 plus 4x is equal to minus 8 x squared minus 2x. So there's two things we need to do. Clear denominators, and to do that we have to find the LCD, and then find all values of x that make the denominators So how do you do that? You set the LCD equal to 0 and solve for x. So the first thing we have to do is we have to simplify this. I'm not going to. We want to factor, we want to simplify any denominator. So we have a denominator, x squared minus 2x. Well, we can factor out, it has a greatest common factor, which is x. So that's x times x minus 2. So I'm going to rewrite this denominator as x times x minus 2. So the LCD is not too hard to find. We want to write down all of the prime factors. So remember, a linear equation, or a linear polynomial, the polynomial in the variable x of degree 1 is linear, is not linear, it's linear too, but that's not the word I want, is prime if the LCD of the two terms is 1. So x minus 2 is 1 prime we have. X is also prime. And this is the factor of 2 prime x and x minus 2. So those are our primes. So I'm going to make the little table over here. So my first denominator is x minus 2. My second is x And my third, really it does a lot of good now that I've drawn it all. And my third is x times x minus 2. So is how many x minus 2 factors are in x minus 2? 1. How many x minus 2 factors are in x? 0. Factors, not how many x's, but factors. How many x minus 2 factors are in x times x minus 2? 1. How many factors of x are in x minus 2? 0. There are no factors. I cannot factor an x out of x minus 2. How many factors of x are in x itself? Of course, exist. And how many factors of x are in x times x minus 2? 1. So these are my prime factors here. So the LCD is x times x minus 2, each raised to the exponent of the largest number in each row. And the largest number is 1. So my LCD is x times x minus 2. So let's set x times x minus 2 equal to 0. Well, that means x is equal to 0, or x minus 2 is equal to 0, which means x is equal to 2. And I want to keep this information here. These are illegal values for solutions. If I get a solution that happens to be one of those values, I throw it out. So I know what the LCD is. So here we go. We enclose everything in parentheses, and we multiply both sides by the LCD. And this is x times x minus 2. So x times x minus 2 divided by x minus 2 is just x. So again, using distribution. So this is x times 3x plus 1. This is x times x minus 2 divided by x, so the x's cancel. But the x minus 2 factor doesn't. X minus 2 times 4. And over here, the numerator is the same as the denominator. I get minus 8. So now let's start. Now it's just algebra. So x times 3x is 3x squared. X times 1 is plus x. 4 times x is plus 4x. So I'm just using distribution here. And 4 times minus 2 is minus 8. And that's equal to minus 8. That's kind of nice. So I have a minus 8 and a minus 8 on both sides. So those two terms are just going to cancel out. And that's really what we wanted to see, because I'm going to go ahead and collect like terms over here. 3x squared. X plus 4x is 5x. And that's equal to 0. Beautiful. Now I factor out the greatest common factor. The greatest common factor of these two terms is x. So 3x squared divided by x is just 3x. 5x squared divided by x is 5. So now I solve. That tells me x is equal to 0, or 3x plus 5 is equal to 0, which easily you should be able to do in your head by now. Means x is equal to 3x is equal to minus 5, or x is equal to minus 5/3. Now these are my two possible solutions, but over here I say that x cannot be equal to 0, or x cannot be equal to 2. So that means this solution here, x is equal to 0, discard it, and my only solution is x is equal to minus 5/3. Okay. So I'm going to stop this right now because I am just shot. I'm beat. And this will be review part 1. So I'm going to tell you what problems I'm going to do later on. So for review, and it will be shorter, but I've got 4 more pages, and I don't feel like doing 4 more pages, people. For review part 2, I'm going to do problem number 23. It's a problem about rates, painting houses in a certain amount of time. I'm going to do number 26, 29, 30, and 33. Okay.